Hello students, welcome to our first lecture of this chapter, that is light. We'll try to cover this chapter in a series of few videos, and we will try to stay true to our syllabus and not go into that much depth, and we will discuss the concepts as much simplified as possible. Okay, so let's start this chapter. First, we can have a discussion on what is basically light, right? You may have heard that light is having dual nature. Light behaves as particles as well as waves, and that is true for light. And we can also say that light is something which enables us to see. It gives a sensation of sight. How does it do that? Basically, light reflects from any object and then it enters out into our eyes, and then we can see that object. Okay, so it is something which enables us to see or gives us sensation of sight. And some of us, or you may have read somewhere, that light is also an electromagnetic wave. You may have read somewhere that light is also an energy. You may have read somewhere that light is made up of photons. So you have all these discussions for light, right? And all of them are basically true. It depends on what we are basically explaining, so we can take the definition of light according to that. Now, as we are in class 10th, so to make our concepts very simple, or to make them understand simply, what we do is we treat light as rays, a bunch of rays who are traveling together parallel to each other. Okay, we also call that beam. A bunch of rays which are parallel to each other, we call it as a beam, parallel beam basically. So if we treat them as rays, it makes our concepts, or it makes our explaining these phenomena very easy, right? So what is a beam? Basically, beam is nothing but a bunch of rays traveling together, right? Bunch of rays traveling together which are basically parallel to each other, right? We call it a beam. Now coming back to this first phenomenon, that is reflection. What is basically reflection? Reflection is something that suppose if we're talking about any particle, suppose we have a ball, so we throw it on a wall. What happens? This ball, after striking the wall, will come back, obviously bounce back from the wall. So that is what is basically reflection. Okay, so similarly the light also behaves like that. When light is incident on a surface, for example, which is, doesn't matter if the surface is rough or smooth like a mirror, the light after striking this surface will bounce back, right? And that is what is basically known as reflection. Okay, so it's not a difficult definition or phenomenon to understand. Now there are two types of reflections. One is regular reflection and one is irregular reflection. Now how do we explain regular and irregular reflection? Suppose I have a surface and this surface is like mirror, right? For example, this is a mirror. Now imagine rays are coming. Suppose these rays are coming, and obviously we are treating them as parallel. Okay, because they are coming from a source, we are treating them as parallel. So after reflection, what happens? That these rays stay parallel to each other because they are striking on a surface very smooth and polished. So after reflection, they are still parallel. So such type of reflection is known as regular reflection. Regular reflection. I hope this is clear. Now if the surface is not smooth, it is rough, for example a wall, it may look, the wall at your home may look smooth, but it is not actually smooth, it is rough. You can see it under a microscope. Okay, so imagine the rays coming back from suppose the rays from any source striking this surface, rough surface. What happens is now that the reflection will be called as irregular reflection, because the reflected rays are going in all directions. They are basically getting scattered all along the places, right? So such type of reflection is known as irregular reflection, where the reflected rays are not parallel after reflection, right? So I hope this is very easy now, right? So now let's discuss laws of reflection. What are basically laws of reflection? Laws of reflection are simply those laws by which we govern reflection. We try to understand under what conditions the reflection works. Okay, so first thing is basically first law, which we call as first law of reflection. And what is this first law of reflection? Incident ray, right, which is basically coming from the source, reflected ray, after this ray strikes the surface, right, and the point of and the normal on the point of incidence. So these are three things: incident ray, reflected ray, and the normal, which is basically on the point of incidence. These all three lie in the same plane. Now what does that mean? For example, you are standing in an assembly line, which is usually held every morning in Indian schools. So imagine you are in grade 10th, and suppose a tall student at the back of the grade 10th line has a ball in his hand and he throws it. Now this ball goes straight and lands at one of the guy's head, one of the student's head in the grade 10th line. Now after landing on his head, this ball, basically made of rubber, I won't make it from any hard ball or something which will hurt students. So this ball, after landing on the head of a student, now bounces and then lands on the other student's head. So what is basically happening here? It is only possible if the ball travels straight throughout the line, right? So when the ball was thrown, it traveled in a straight line and then landed on one's head and then bounced and then went straight. That's only possibility how the ball could have hit or landed on the other one's head, right? It didn't go to the grade 9th line or grade 11th line. So that means the ball didn't change the plane, right? This grade 10th assembly line can be considered as a plane, right? So similarly, when the light comes, it goes in a straight line, it goes in a straight plane, right? Like imagine a page of paper, a straight page of paper, that can be considered a single plane. So light comes and goes straight, bounces back and then goes straight. It doesn't change planes. Like if you have seen cricket, in bowling, the spin is something which like deflects, the ball is deflected in another planes. Or swing, when the ball is swinging, it is going from one plane to another and then coming back, something like that. So light doesn't do that. Light always travels straight. So this is our basically first law, that incident ray, reflected ray, and the normal at the point of incidence is basically all of these three lie in the same plane, right? Now when we discuss about second law of reflection, what is basically second law of reflection? It is a very easy law, that angle of incidence is equal to angle of reflection. We have all heard about it, right? So let me show you. So suppose this is our surface and this is our incident ray. So this is basically the normal at the point of incidence. This is basically the normal at the point of incidence, and this is our reflected ray, right? So suppose this is our angle of incidence and this is our angle of reflection. So the second law says that angle of incidence is equal to angle of reflection. As simple as that. Now we may have a misconception that this angle of incidence is equal to angle of reflection works only in regular reflection. It is not so. Angle of incidence is equal to angle of reflection. It works in regular reflection as well as irregular reflection. Let me show you. Suppose if we are talking about a regular reflection, so suppose this ray is coming like this, and this is our point of, suppose this is a normal at the point of incidence, and this is your angle of reflection. So here obviously, now imagine I have got two rays. Suppose this is another ray and this is its reflection, and this is, suppose, its normal. So what do I see here? Suppose I call this I1 and this is R1, and another one I called R2, this I2 and R2. So in regular reflection, suppose I can say I1 is equal to R2 also. It doesn't matter which rays angle of incidence you are taking and which rays, some other rays, angle of reflection you are taking. It is basically same for every ray in regular reflection. But for irregular reflection, it doesn't work like that. Suppose you have an irregular surface. So if you take, suppose, first ray's angle of incidence, only first ray's angle of reflection will be equal to the angle of incidence of that ray. You can't equate angle of incidence of first ray to the some other ray's angle of reflection. It doesn't work like that, right? So in regular reflection, anybody's angle of incidence will be equal to anybody's angle of reflection. Angle of incidence is equal to anybody's angle of reflection, and in irregular reflection, only same ray's angle of incidence and angle of reflection are equal. You can't equate anybody's angle of incidence to anybody's angle of reflection. I hope that's clear. So see you next video.